Hello everybody, Miss Germany here again. Still working on our multi-step equations. So this is going to be example 2 using our solving equations decision chart here. So my equation this time says 4x plus 3x plus 5 equals 47. All right, so we start at the top of our decision chart. Are there fractions or decimals to be removed? Well, I don't see any fractions or decimals, so again, my answer this time is going to be no. And I come down. So my question 2 says, does distributive property need to be used? Well, remember, with distributive property, I would have parentheses, and I don't see any parentheses. So nope, I'm all good. I can say no and come down again. Question 3, are there like terms on the same side of the equal sign? Now, note the same side of the equal sign. We haven't done anything yet, so one of the first things I'm going to do here is I'm going to go ahead and draw my line so I can see the sides of the equal sign. Just helps me visualize. So I'm going to look now at this side of the equal sign. And do I have like terms? Well, I have 3 terms, so that's pretty much a guaranteed something's got to be like. So the method I tend to use is I take whatever my first term is and I just give it a single underline. Now that has a variable, so any other term that includes a variable is also going to just get a single underline. So that's 4x. 3x also has a variable. That's a single underline. But 5, that's just a constant, so that's going to get 2 underlines to show that it's different from the other 2 terms. All right? So my answer is yes, there are like terms on the same side of the equal sign, so I'm going to follow it yes over. And it tells me combine like terms, and I can cover up one side at a time if that helps me. So if you're working with a paper copy and it gets really, really messy, you can cover up the 2 sides, or you can just use the line. So I want to combine my like terms. So the terms that are the same are 4x plus 3x. So I'm going to just add the 2 coefficients. 4 plus 3 is going to give me 7 and keep the variable x. Then I just bring down the constant 5 because it did not have a like term. And on the right hand side, I'm also going to bring down the 47 because it's the only thing on that right hand side. All right, so I now combined my like terms, and I'm going to then come over to the next question. Are there variables on both sides of the equal sign? Well, again, I do have a variable on the left, but on the right, I only have a constant, so the answer to this one is no. So I'm going to follow it down. Next question. Are there constants on both sides of the equal sign? And by the time you get to here, you're going to have either a 1 or a 2-step equation. So are there constants? I have a constant of 5 on the left, a constant of 47 on the right. So the answer this time would be yes. So I'm going to follow the yes. And I add or subtract to move that constant away from the variable. All right. So 5 is the one on the same side as the variable. I am going to subtract because 5 is positive. So I am going to do inverse operation, which would be subtraction. And what I do on one side, I do on the other. So I'm going to subtract 5. That gives me a positive 5 minus 5. Those cancel out, leaving me with 7x on the left. And then 47 minus 5 gives me 42. All right, so I did my add or subtract. So then, is there a coefficient with the variable? And again, coefficient with the variable is a number immediately next to it. So yeah, there is a coefficient 7. That coefficient is held there by multiplication. So the inverse operation is division. So I'm going to divide by 7. And again, what I do on one side, I do on the other. The 7s will cancel each other out. They're on my left, leaving me with just x, which is exactly what I wanted. And then on the right, 42 divided by 7 gives me 6. And now I am solved.